Students, in this question they give us the percent by mass of one of two elements in a compound, and they give us the molar mass. And that's it. It's very little that they give us initially. And from that they want us to determine the empirical and molecular formulas. This problem is a combination of the work that we did in question 2 and in question 3 of this WebAssign. So let's start just with a little simple math. If they're telling us that this compound is 69.6% sulfur, and there's only sulfur and oxygen in it, that would have to mean that the rest of the percentage, 100 minus 69.4, which would be 30.4%, would have to be the other element, nitrogen. So now we've got the percent by mass for each of the two elements. Let's start with our normal steps. If they give you a percent by mass for elements in a compound, first assume a 100-gram sample. And what that allows you to do is to take the percentages and just convert them into grams. So in a 100-gram sample, if 69.6% of it is sulfur, that means 69.6 grams of sulfur are present. And if 30.4% of the sample is nitrogen, that means that you've got 30.4 grams of nitrogen if it's a 100-gram sample. Secondly, let's convert grams into moles. And the way we'll do that is divide by the atomic weight of each of the elements. So we've got sulfur, 1 mole of sulfur. If you look up on the periodic table, you'll find 32.1 grams. And for nitrogen, 1 mole of that is equal to 14 grams. And by crunching those numbers, so I'll take 69.6 divided by 32.1, and I get 2.17 moles of sulfur. And I'll also take 30.4 and divide it by 14, and lo and behold, it works out to be the same number of moles. So that you might be able to visualize to the end point here, but let's work through the steps even if you can see the empirical formula at this point. Once you've got numbers of moles for each of the elements in a compound, we're going to write a provisional formula with decimals as subscripts. And of course that's improper, but we don't care because that's the way we can get to the answer. So if they tell us, or if we had worked out that there is 2.17 moles of sulfur, let's write a formula with S and the subscript 2.17. Similarly for nitrogen, we had worked out that there's 2.17 moles of nitrogen, so let's put an N and the subscript 2.17. Next, we divide all of the subscripts in that provisional formula by the smallest of the subscripts. And after doing that division, look for whole number ratios. You'll find whole number ratios in the easier problems, but sometimes we'll see in the harder problems, you'll see ratios that end up with like 3.5 or 3.33, that would be a third, or 3.25, that would be a fourth. So look for halves, thirds, or fourths in addition to whole numbers. So, okay, the smallest subscript, well, it's a tie for lowest place, smallest place. In this one, divide 2.17 by 2.17 and you get 1. So S1N1 would be your empirical formula. Usually you just write that as Sn without the subscripts 1. Okay, so this is your empirical formula. That's half the problem. And that's very helpful. But the other piece of this problem is that they give you the molar mass and they say, okay, find the molecular formula. Well, this is just like an earlier question in this WebAssign. What we'll do is find the empirical formula mass. So if you know the formula for the empirical formula, just find that mass like as though it were the molar mass in any other problem. So looking up sulfur's atomic weight, it's 32.1. Nitrogen's is 14. Add them together and you get 46.1 grams per mole. That's your empirical formula mass. Then if we take the molar mass, which they gave us in the original problem, of 184, and divide that by the empirical formula mass, you should get a whole number. So when I punch 184 divided by 46.1 onto the calculator, I get a number that's really close to 4. So that number, that 4, is what we're going to multiply the subscripts in the empirical formula by in order to arrive at the molecular formula. So in the empirical formula, it was S1N1. The molecular formula then would be S4N4.